Welcome students. We have started about magnetic field, what is magnet, and what is magnetic field lines, and the properties, some properties of field lines, some important properties of field lines. Okay. So, and also we have studied that Earth is a large magnet. It has south pole um, towards north direction and north pole towards south direction. And so today we will study more about that. So field line in uniform magnetic field lines. Magnetic field it same everywhere in the region. If I choose a region, suppose this is a region where magnetic field uniform, means magnetic field that point, this point, that point, that point, all the point has same magnitude and same direction. That means the field line will be along same direction. Okay, along same direction. And as the magnetic field intensity define the number of field line per unit area, means field line will be number of field line per unit area will be same. That means the distance between two field line will be same. Okay, so in uniform magnetic field the property of field line will be parallel and equidistant. Okay, in uniform magnetic field line will be parallel and equidistant. So we can create also uniform magnetic field by using two bar magnet. If I place two bar magnet very closer, means north pole of one is south pole is another, then the field line emitting from north pole enter to the south pole, and this field line nearly uniform. Okay, and this region or middle region of the NNS, this region has uniform magnetic field. Okay, there is uniform magnetic field in this region. This is called uniform magnetic field. And another term is neutral point. Neutral point means the point where net magnetic field is zero. If I put two same pole, if I place two same pole side by side, then you can see, if we know the field line is the motion of a isolated north pole. If I put a north pole here, then this north pole also repel that north pole, and the north pole this also repel the north pole, then this north pole will go along this path maybe. Okay. And we get a point region where net magnetic field, this region will be zero, because magnetic field due to left north pole and magnetic field due to right north pole is equal and opposite direction. Okay, then this point is called neutral point. Okay, this is called neutral point. Okay, and now magnetic field of Earth. I have told that Earth is a large magnet. Okay, it has geometrical north south. Suppose this is a geometrical north south, and Earth magnetic field lines emitting from south pole and entering into north pole. Okay, like that. If we show in 2D the right side picture, you can see that the north south magnetic north south is called magnetic axis, and the geometrical north pole and south pole is called geometrical axis. Okay, and also there is a equator, geometrical equator. This is called geometrical equator, and there will be also a magnetic equator. I will show now. Angle of declination. Angle of declination means the angle between geometrical north pole and magnetic north pole. If magnetic north pole, you know, this is the east, west, north and south. If the magnetic north pole is towards east direction, then the declination is positive. Okay. If magnetic north pole is towards west of true north pole, then declination taken as negative. Okay, this is called angle of declination. And you can see here the magnetic north south and geometrical north south. This is a magnetic north south and this is a geometrical north south, and this is called geographical equator and this is called magnetic equator. Then another term, neutral point, due to a bar magnet in earth magnetic field. Okay. So we know earth is a magnet and its magnetic field south to north. Okay, just let me show you. Just like that, the magnetic field lines are, for earth magnetic field is directed like that. Okay. These are the earth magnetic field. Okay. But and also for this bar magnet, the magnetic field lines emitting from this north pole, okay, and entering into south pole, just like that. Okay, you can see the north field line due to bar magnet and field line due to earth magnetic field are in opposite direction on the perpendicular bisector region of this bar magnet, like that region and that region. Okay, so in this region the magnetic field due to bar magnet and magnetic field due to earth magnet in opposite direction, and there maybe we can get some point where net magnetic field will be 0. These points are called neutral point. Okay. Then for earth magnetic field we can draw like that, like that. So you can see the right side picture, that just like that. These are the magnetic field line due to bar magnet and these are the magnetic field line due to earth magnetic field, and you can get some neutral point. Okay, also this clear. And if we rotate this bar magnet 180 degree, means if we place a bar magnet south pole towards north direction and north pole towards south direction, then what will happen? These are the field line due to earth magnetic field, but for bar magnet, field lines entering into south pole and emitting from north pole, and for bar magnet field lines are like that. You can see that in axial region, that point, the field line due to earth magnetic field and field line due to bar magnet are in opposite direction. For bar magnet, field line is downward. For earth magnetic field line are upward. Then you can get a neutral point. Okay. And for down point also you can get a neutral point here, because of the field line due to bar magnet and field line due to earth magnetic field are in opposite direction. Okay, these are the neutral. You can see the right side picture well drawn. Okay, so more about bar magnet. For a bar magnet, if I try to explain the internal property, I have told that each atom act as bar magnet, like that. A bar internal atom of bar magnet, and maybe there is some north south oriented along same direction. Okay, yes. In middle region there is also ns. In middle region, n pole and s pole are close together so that they can cancel out each other. Okay, so net magnetic field in middle region near about 0, not exactly 0 but near about 0. But magnetic field, the in side region you can see the empty north pole here, and in left side you can see the empty south pole here, and these south poles repelling each other, that's why they are just like that, they are moved away from each other. Okay, but that's why the south pole and north pole are placed to end of a bar magnet, not the middle region. But and the north pole and south pole are not exactly the outer position. These poles are slightly inside the bar magnet. Okay. So the actual length of the bar is not equals to the length of the bar magnet. The length between two pole. Okay, LB. So actual length between two pole is less than the length of the bar. Okay, and the magnetic there is no pole or empty pole middle region of a bar magnet. That's why if we put an iron or steel, then it will go towards north direction of a bar magnet or towards south direction of a bar magnet. It will not stay at the middle region of a bar magnet. Okay, that's all for today's class. Goodbye.